I will say weed indices. So now you just remember, we will go first. We will go weed control efficiency. This is the, I will say, weed control efficiency. Okay. Second, we will go weed control index. Weed control index. Okay. Third, you will see weed index. This is WI, weed index. This is also known as weed competition index. This is also known as weed competition index. Okay. So now in today's class we will focus these three things. Okay. So first two parameters. One is weed control efficiency, and another is weed control index. Weed control index. These parameters are based. Always remember, these two parameters are based on the weed data, whereas weed index is based on the plant data, or you can say the crop data. That means if you want to calculate the weed control efficiency and weed control index, then you need the data regarding the weed. But if you want to calculate the weed index or weed competition index, then you need some plant data. So now here I will see weed control. First of all, we will come to the weed control efficiency. Here I will write weed control efficiency. So if I will write weed control efficiency, then first of all I will go for the formula. What is the formula? Here the weed control efficiency, it is the weed population. It is the weed population in control plot minus weed population in treated plot divided by weed population in control plot percentage. So just multiply 100. This is the simple important thing. So first of all I will define these things. Weed population, that means, let us, I am taking, this is a field. This is a field. Okay. So here different herbicides are there. Let us, this is a control plot. Control plot means control plot. What do you mean by control plot? Control plot means where no herbicide is used. No herbicide is used, or no control measure, or no control measure is taken. This is known as the control plot. Okay. So another plot will be there, which is weed free plot. I will say weed free plot. Here we can go for hand weeding. Here we will go for hand weeding twice or thrice, 3 times or 2 times hand weeding will be there, so that the plot will remain completely weed free. Okay. But in case of control plot, there will be no control measure. So whatever the weeds are there, you have to just maintain. So no maintenance. So you, whatever the weeds are there, just keep as that. Okay. So no control. So now I will take herbicide. That is, this is herbicide 1, this is herbicide 2, this is herbicide 3, 4, 5, 6, 7, 8, 9, 10. So I have taken 10 herbicides. I have taken 10 herbicides. These 10 herbicides either may be different herbicides or may be different dose of herbicides. Okay. So here herbicide treatments, I have taken 10 herbicide treatments. These are the herbicide treatments. Herbicide treatment. Okay. This herbicide treatment, this may be either different dose. Let us, I can say, this is the, I am saying that this is pyrazosulfuron. This is pyrazosulfuron ethyl. Okay. So in the so I will take different dose. Pyrazosulfuron ethyl, I can take 200 gram per hectare. Okay. Or I can say another dose will be there 400 gram per hectare. I can say 100 gram per hectare. So same pyrazosulfuron ethyl having different dose. Or I can say different herbicides are also there. I can take alachlor, then pretilachlor, then bensulfuron, then I can say 240, whatever the herbicides, number of herbicides can be taken. Okay, so these are known as the treatments. These are known as the treatments. So in the plot, I will get three type of plot. One is plot where there is no treatment. Yes or no? I will get three type of plot. Okay, one plot where there is no treatment, so weeds are there. Here, weeds are there, and another plot where weed is not there. There I can say almost absence of the weed, and other treatments are there having small weeds are there. Small number of weeds remain because they are the different herbicide treatments. So some of weeds may die and some weeds may remain in the field. Okay. So these are the three things. So if I will say the weed population WPC. Weed population, here I can say the weed population WPC. WPC means weed population in control plot. Okay, control plot. First of all, we have to understand what do you mean by weed population. Population means you know that population means number of weeds per meter square, or we can say what are the number of weeds per unit area. This is known as the weed population. So you just think here, out of this, so this is 3, 6, 9, 12. These are the, I have taken 12 treatments. Okay, 12 treatments I have taken. So you just tell me approximately which plot has the more population. Obviously control plot, because here the population is very less. Yes or no? So here the control plot means the weed population is very high. Sorry, here the weed population is very high because there is no herbicide treatments. So the weed growth is more in control plot as compared to other plot. So here we can say, always remember, control plot means the, so this will be the highest value. Yes or no? Out of the total treatment, this is the highest value. Okay, this is the weed population control. This is also highest value. Now this is a weed WPT, means weed population in treated plot. Which plot? Treated plot. So now, if I will say treated plot, how many treated plots are there? Except control plot, all the 11, total plot is 12. So except control plot, the remaining are known as the treated plot. Okay. So here, if I will go calculation for the herbicide 1, so here I will go. So now for herbicide 1, for H1, I will calculate the weed control efficiency. Then I will say the weed population in control plot minus weed population in herbicide 1 plot divided by weed population in control plot. Sorry, my health is not good. Okay, still I will try. Okay, I will try my best. For herbicide 2, the weed control efficiency is WPC minus weed population in herbicide 2 treated plot divided by WPC. Okay, so likewise we will calculate from up to herbicide 10 and another is weed free plot, particularly the weed control efficiency. Okay, so in weed free plot, if it is completely free, then I will say in weed free plot, in weed, here I am saying in weed free plot, if it is completely free, that means the weed population WPC minus it will be 0. Number of weed population in weed free plot is 0. Then divided by WPC, which is equal to WPC by WPC is equal to 100. Yes or no? So the weed control efficiency if the weed free plot is completely absence of weed, then I can say it is 100% weed free. Then the weed control efficiency will be 100%. Okay. So if I will say that, so the weed control efficiency here I can say the weed control efficiency of control plot is 0. Yes or no? If so here I am writing weed control efficiency. Weed control efficiency. Here is a treatment. So if I will say the first treatment here is control plot. So in control plot, the weed control efficiency will be WPC minus WPC by WPC is equal to 0 by WPC is equal to 0. So control plot, the weed control efficiency is 0%. And I will say weed free plot, if it is completely weed free, then the weed control efficiency is 100%. Yes or no? Then whatever the remaining H1 to H10, the percentage is between 0 to 100%. Okay? The weed control efficiency of the remaining herbicide is 0% to 100%. Okay? So here I can say if the weed control efficiency is more than the herbicide, let us herbicide 10 has the weed control efficiency is about 90%. That means it is better than other herbicide. Let us herbicide 1, the weed control efficiency is 60%. That means the herbicide 10 is more efficiently controlling the weed. Weed control efficiency means what? The term itself shows that weed control efficiency, how efficiently a herbicide will control the weeds. Obviously. So if the weed control efficiency percentage is high, that means that herbicide will control more efficiently as compared to other herbicides. Okay. So here if the herbicide 10 has the weed control efficiency 90%, then it is better than the herbicide 1. Okay. So this is the basic thing you have to understand. So weed control efficiency, I think you have understood. Okay. So weed control efficiency for a weed free plot, it will be 100%. For a weed control plot, it is 0%. So here I can write weed control efficiency. Higher the weed control efficiency, higher the weed control efficiency, then higher will be the efficiency of herbicide to control the weed. Or we can say if higher the weed control efficiency, then I can say it is good. Yes or no? Higher the weed control efficiency, then it will be good. So whatever the herbicide we are using, so I need the weed control efficiency should be more, then it will be more efficient, more beneficial. Okay. Next, coming to weed control index. So here weed control efficiency, they both are similar. In weed control efficiency, I am taking the weed population. Weed control efficiency, I am taking the weed population, or we can say density. means population per meter square. But in weed control efficiency, I will take the dry weight of weed. Which parameter I will take? Dry weight. So here I will take the weed dry weight in control plot minus weed dry weight in treated plot divided by weed dry weight in control plot into 100. So here I will say weed dry weight, WC weed dry weight in control plot, WDT weed dry weight in treated plot. Okay, so you just here calculate. In WCE, what do we have found? We have counted the weeds per meter square. But here for WCI, weed control index, I have to use another extra step. So first, what we will do? First, take all the weeds. First per meter square. So just take the meter square. Just take the meter square, and you just take all the weeds, and urban dry. Go for urban dry. Okay. Urban dry for for weed for plant species we are going for the 65 degree centigrade urban dry will be there. Exam asked whatever I am teaching, definitely 1 to 2% will be asked. Okay. So 65 degree centigrade will be used, and for this condition you just take the dry weight. Okay. Likewise, you take all meter square value, all meter square weed, and just urban dry weight. Record the urban dry weight. Now put the value. Okay. So if I will put it similar, this is also similar. So the weed dry weight will be maximum in case of control plot, and the weed dry weight will be very minimum in the weed free plot. Okay. So likewise, you will put the data and get the answer. So likewise, if you will say the weed control index of control plot. If I will say control plot, then weed control index will be likewise. It is similar to WC. Of weed free plot, the weed control index will be 100% if it is completely weed free, and other herbicide 0 to in between 0 to 100%. Here also higher the WCE. Here also I can write higher the WCE. Here also I can write higher the either WCE or WCI, then it will be more beneficial. Okay. So the herbicide we just calculate the weed control efficiency and the weed control index for each individual herbicides, and here I will say the herbicides having the higher value, it is more beneficial. Okay. Next, coming to weed index. I have already told this weed index is based on the which data? This is based on the which data? The plant data, plant yield. Okay, yes or no? So here we will see the plant yield. Okay. So now you tell me, I have already told whatever value you will take, high minus low divided by high into 100. Yes or no? So you just tell me if you in the exam if in the exam you just forgotten the formula, then it is very easy to remind it. This is the trick. You just remember high minus low divided by high. So high. You say in which plot the yield. I am saying here plant yield will be taken. Okay. For weed index, plant yield will be taken. So you say here high minus low. High means in which treatment the plant yield will be high. In which treatment? So here I will write yield, plant yield is inversely proportional to the weed population, or I can say it is also inversely proportional to the weed dry weight? Yes or no? Very simple. If the weed population is high, then the yield will be less. If the weed population is very less, then the yield will be high. Obviously, because there is a crop weed competition. If the crop weed competition, you know. So if the weed component is less, the yield component will be high. If the weed component will be more, then yield component will be less. Very simple. So you say, out of these 12 treatments, which treatment has more plant yield? Obviously, where the weed population is less. Here the weed population is less in weed-free plot. So you can say the plant yield in weed-free plot divided by high, say plant yield in weed-free plot. So plant yield in weed-free plot minus plant yield in treated plot. Yes or no? Plant yield in treated plot. Okay, into 100. Plant yield in weed-free plot minus plant yield in treated plot divided by plant yield in weed-free plot. This is very simple. So here in some book it is written as x minus y by x into 100, where x is the plant yield in weed-free plot, y is the plant yield in treated plot. So if I will say, then the lowest value, the lowest WI, the lowest weed index, I will get from which plot? The lowest index. Okay, now you can just hear thing. Now this is constant. My question you can understand my question. I am saying that out of these 12 treatments, in which case the lowest weed index will be found. The lowest weed index will be found. So here I can say the lowest. So what will be the very lowest? Here I am saying that, let us see for herbicide 1. For herbicide 1, what will take? For herbicide 1, what will be the thing? For herbicide 1, the weed index for herbicide 1, this will be x minus h1 divided by x into 100. Yes. For weed index for herbicide 2, this is also x minus h2 divided by x into 100. Weed index for herbicide 3, it will be x minus herbicide 3 divided by x into 100. X means the yield from the weed-free plot. X means yield from the weed-free plot. So you just say, in each case, I am saying, just notice, in each case, x remains constant. Here the denominator, you can say the denominator. The denominator remains constant, yes or no? So in each case, the denominator constant. Denominator remains constant. This is the fundamental principle. Denominator remains constant. So, you know fraction. Fraction is numerator by denominator. But here in each case, the denominator is constant. So I will say the denominator is so now I will ask question 1 by 3, then 2 by 3, then I can say 1 by 2, this is 5. This is 5. 1 by 5, 1 by 5, then 2 by 5, then 3 by 5, then 4 by 5. Out of this 4 fraction, which one is less? Obviously 1.5 is less. That means if the denominator is constant, then the numerator value, if it is lowest, then the total fraction will be less. Likewise, here the denominator is constant. So I will see where in which case the numerator fraction will be less. If the numerator fraction of this Wx3 will be less, then it will be the which the weed index will be high. So here I can say, so you just remember here, lowest weed index. So lowest weed index I will get in which case? If I will get lowest numerator. Yes or no? Lowest numerator. Lowest numerator. I will get lowest numerator. Obviously. So now I will take, here it is the plant yield. Let us x means, let us, this will give 6 ton. The yield is 6 ton. Now herbicide 1 H1 will give, let us think it is 3 ton. Herbicide 2 it will give 1 ton. Herbicide 3 it will give 5 ton. Okay. So now here you can say, now here the difference, now x, now I will say x is 6 ton, x is 6 ton. So here the difference is 6 minus 3, the difference will be 3. Here the difference will be 6 minus 1, 5. Here the difference will be 6 minus 5, this is 1. Okay. So that means I am saying that lowest numerator means lowest weed index. Here, so here lowest weed index will be get in WIH3. WIH3. So here you can also say that here the yield is highest among the herbicide. The yield is highest in H3. That means I can say out of H1, H2, H3, the H3 yield is better. If the H3 yield is better, then it is good or bad? That herbicide is good. Obviously, I have already told, if the herbicide is good, how you can know the herbicide is good? The herbicide is good if the weed dry weight is less. If the weed population is less, then only the plant yield will be high. Here the plant yield is high in case of herbicide 3 among these 3. That means I can say the lowest weed index is more beneficial. Here you can say the weed index value is lowest in H3. So the lowest value weed index is more beneficial for a herbicide or for a practice. Okay. So this is the thing you have to remember. Again I am saying for exam point of view. Okay. So I just remove these things. For exam perspective, I will tell the data. Okay, you just remember W control efficiency, weed control efficiency, and weed control index. This is based on weed data. Yes or no? Higher will be the value, then it will be more beneficial. Then it will be more beneficial. It is good. Higher. But in weed index, if I will say weed index, then here plant yield will be there. Plant yield data you require, and the lower the value, then it is more beneficial. Then it will be more beneficial. This is the thing. You just remember. Okay. This is the weed index where we have already covered. We have covered weed control efficiency, weed index, and weed control index. So this you have to remember these two things. What is the difference? Weed control index, another is weed index. Okay.